So this is the P38 cooling system as it comes from stock. You have the engine. The engine heats up the water that comes to the radiator. The radiator has a way in, a way out on the top of the radiator because the radiator is split. So the water comes in, goes down, comes up, a bit cooler, and the pump pulls the water to the engine again. And we have also a way out on the back of the engine that goes to the cabin heating radiator, and the hoses have an O-ring to prevent water to come out, and this is prone to failure. The rings get a bit dry, and there may have occur leaks in the cabin. So the water hits the cabin, comes out. There's a T-hose here that pulls or pushes in the water in the expansion tank. So the coolant, if needed, goes to the inside to the front of the engine, and the water pump puts the water in the engine. So one change that I made to my P38 was to install a bypass valve, 2 valves here on the back of the engine. And if I have some trouble within the cabin heating radiator in the O-rings, or if the radiator has a crack or something, I bypass the flow from the radiator directly to the engine, and I cut the way out from the radiator also with a valve. With this 3-way valve and this cutting valve here, I can remove the cabin heating radiator and continue my journey without having to stop if I have some trouble with the heating radiator. I have a valve there that closes the water to the cabin climate radiator, and another 3-way valve that makes a bypass from the engine directly to the expansion tank. The second change I made to the cooling system was to replace the cooling radiator by an all-aluminium radiator for better performance and better cooling. The original radiator had some parts in plastic, so I changed for a completely aluminium radiator, and it performs much better cooling. The third upgrade I made was to replace the return pipe from the radiator to the expansion tank. This return pipe provides some balance in pressure. If there is some obstruction on the radiator, on this flow, the pressure can bypass and level the expansion tank. By other hand, for the level here to go down and up, it needs to have flow from another place. But the original makes some turns and twists to get here. So if there is some air on the top of the radiator, it keeps there and goes inside the engine by the water pump. Some air is more difficult to take to bleed. So I replaced the original tubing that makes several turns until it reaches the expansion tank, and I put a direct hose that goes always up from the radiator to the expansion tank. This way, some air that is on the top of the radiator goes to the expansion tank. So in this case, I put this pipe, this hose that goes here, always going up until it reaches the expansion tank. So this way, if some air is on top of the radiator, doesn't go down inside the engine, but goes quicker for the expansion tank. There's no need to bleed the radiator because there's always a path for the air go to the expansion tank. Now I have a problem with my P38. I have a problem with pressure buildup. I feel the tubes very hard after engine running. When the engine is hot, the tubes are very hard and the water starts to come out. I put this bottle here. It's almost nothing, but after a while it starts leaking by the expansion cap, starts leaking some coolant. So I'm pretty sure that is something with maybe a head gasket. So why do I think I have a blown gasket or a block crack and not a faulty radiator cap, not a clogged radiator, nor a damaged water pump? That would be other symptoms. A faulty radiator cap, if there's a problem here, when I take the cap off, with the engine running, the water should be there, should not put the water out. A clogged radiator, okay, could be, but in that case the engine would hit, because the water wouldn't flow and the car doesn't hit. It doesn't heat up, it works normally. So a damaged water pump also would stop the flow here, or a clogged radiator, and the temperature on the engine would go up, and it doesn't. So I guess it's not that. With a blown head gasket or a block crack, it means that there's some pressure from the engine that goes to the pipes or to the water tubing and water where the water flows, and those gases comes to the radiator and pushes the water. And so where those that air goes, if there is air in the system, well, it will go to the expansion tank. So if there is more air here, it builds up the pressure around, and if the pressure increases, the cap will open and will leak out some coolant, and that is what is happening. Another test I made is with the cap off. If I block this hose here inside, so the pressure doesn't come here. Where does the pressure go? The pressure increases in the system here, and the water starts to go up. The pressure increases and starts to go out from the cap. So if I release this passage here, then the pressure, the gases and the air comes here. The water doesn't go up, but I feel that there is some gases, air going in this way. You can see here that when I block the tube that comes from the radiator to the expansion tank, the gases start appearing in the water in the expansion tank. So for this problem, what is the solution that I'm trying to do? I will use the lock solder. It works okay when the problem is in the beginning, not for a very high build-up pressure, just a little bit. That's what I'm having right now. So how does this block solder works? Well, if the problem is on the engine, there's no need, and I should not put any products on the radiator, on the cooling radiator, nor on the heating radiator. So what I'm going to do first is to block the passage to the cabin heating radiator, and the coolant will flow not passing by the cabin radiator. The same thing I will do here on the cooling radiator. I will disconnect the coolant, the cooling radiator here and here, and I'll make a hose that goes like that. Okay, this way the water will flow only in the engine and in the expansion tank, not in the radiators. Then I need to find on the block where I can put the water out from the system. In the P38, the way out and the way in of the water is a very high position. So when the coolant is all out, I will put water on the system, on the expansion tank. I'll start the engine a bit to heat up just with water, and I will drain again. I'll take that for the coolant to be all out from the system, only water. Okay, so the engine will be with only water, and then I'll drain the second coolant. That will be the water. So I found that there is a bolt on the block just behind the turbo, near on the lower part of the block. If you take out that bolt, all the water in the block in the engine will go out. I also found that bolt on my car, it has some sort, it's not okay, it is broken somehow. I don't know how that bolt got this way. I drained and I put it back, but it's not normal that bolt be this way. After draining the engine for the second time, from the first time is the coolant, okay, the second time is the water that I'm going to put out of the engine. I will replenish the system only with water, and I'll put the engine running for about 7 to 80 degrees Celsius. And when I reach that temperature, because I have a temperature gauge on the car, when it reaches that temperature, I will stop and I will put the block solder in the system, and then I will put the engine working until it reaches around 100 degrees Celsius, until it starts boiling. So when it reaches that temperature, I will stop, okay? And once the system is with pressure, because it has a build-up pressure and is hot, the pressure will try to imagine that there is a crack on the gasket, a crack there. So the pressure will take the product, the water and the block solder, through that crack, okay? So when the engine is hot, I will leave it, I will stop the engine and leave it there for 1 hour, okay? This way the pressure will try to fill the crack on the other way, on the reverse side, because the engine pulls pressure in the system. Now if I have the system with pressure and the engine is stopped, the water tries to go back where is lower pressure to the engine through the crack. So the crack will be with water and the block solder, okay? After that I will try for the third time the drain, okay, the water plus the block solder, okay. I will try to drain the water and block solder and leave it there for 6 hours, 6 to 8 hours during the night, okay. And only the next day I will pull the system again with coolant. I see people more than one time using these products the wrong way. They just put it on the expansion tank and start the engine running and hoping that this will fix everything. But if you read carefully on the instructions, it says clearly you need to disconnect the block from radiator and water pump. Well, I won't do it from the water pump. I just will disconnect it from the radiator and from the heating cabin radiator. Empty and rinse the block, okay? The second using water for the second time. Turn the engine on until it reaches 7 to 80 degrees, okay? Stop the engine and add the block solder. Turn engine on again until water begins to boil, okay? Empty again with the warm circuit. Let it act for 1 hour. Here in the radiator I will disconnect this hose and also this hose, and I made this tube. I will connect this tube here and another this way here, so this way I will have the engine coming from the engine, the water, and goes again to the engine, not passing the radiator. Here you can see that I also made a change to this bypass tube, adding that red tube for the water to go to the expansion tank and can flow freely and not having the air in the system. I controlled the temperature as the engine was running. I have a temperature gauge that now reaches 100 degrees Celsius, and at this point is already on 120. And I also have a warning a sound warning that when the engine reaches 100 degrees it starts beeping. So I know the red light there tell me that the engine is already hot, and in this button I can switch on or off the buzz, the sound warning, and you can see on the gauge of the car that it's hot, but it's not that hot. I know this because I have set up the gauge to read the temperature on the hottest part in the engine, that is around the 6th cylinder. By other hand, I have the temperature warning set up on the 1st cylinder, and is set up for 100 degrees Celsius. I know that when the car gauge is around pointing like this, I have the car on the 1st cylinder in the front of the engine around 100 degrees Celsius, and the sound warning starts beeping. And I know that in the back of the engine it's a bit hotter, around 120. And after this, the pressure buildup was gone, and I have the P38 ready for new adventures in the desert or in the snow. Let's see what comes. See you next time. Bye bye. Thank you.